Uh, Mixed exercise 9, question number 1. A car accelerates in a straight line in a constant rate, starting from rest at point E and reaching to a velocity 45 km/h. So the velocity time graph starting from rest, and it is reaching to a, this is 45 km/h minus 1. So we'll turn into the SI units. So this is going to be 12.5 MSY. So this is 12.5, and this is velocity ms minus 1, and this is t second, and this will reach with 20 second. Uh, the velocity maintained, the car passes point B at 3 minutes. So it is maintained 3 minutes mean 180 seconds. Let's say up to here. So this is 160, then 180 minus 20, 160. Part A, sketch the velocity time graph, which is we did, and part B, find the displacement of the car. So displacement of the car is area of VT graph. So that is going to be half area of the trapezium. That is the standard formula. So I will take this distance because this is the parallel lines. 180 plus this is 160 times h is going to be perpendicular height, that is 12.5. So this answer is going to be 2125 meters. So distance from A to B is 2125 meters. Question number 2. A particle is moving to this direction or OX direction from t equals 0 to t equals 32. The particle is traveling with the constant velocity. This is 32. So constant velocity 15 ms minus 1. And then particle decelerate from 15 ms to rest after t seconds. Is the velocity time graph. So from starting point it is f15 minus 1, and this is 32, and after 32 seconds it will decelerate t seconds, and after t second it will come to rest. So A is done. B, total distance traveled by particle 500 and S equal 570 meter. So find T. So find T. So this is given mean we can write the distance as an area from here and only one unknown, that is T. So S equal, again S equal half A plus B times H, half this distance is 32 and this distance is 32 plus T times perpendicular height is 15. So this is going to be half 64 plus T times 15. So this should be equal to 570. So half, so this is 1, this is 2. From 1 and 2, half 64 plus T times 15 equal 570. 60 plus 4 times T times 15 equal 1140, multiply by 2, then I can divide by 5. We'll see, this is 3, this is 2, and 14, still 2, 48. I think I can divide by 3, this is 7, and 18, 6. So 60 plus T equals 70, 60 equals 70 minus 64, that is 12 uh, 12 seconds. Part C is we need to draw a displacement time graph for this one. So we know that VE is ds over dt. Displacement time graph, which is S displacement time graph. The gradient will give the velocity. So if gradient is constant, mean it has a constant velocity. When you find the gradient, if we have 15, and when you find the gradient of this one, if we have 15, this point, basically this is a line, everywhere gradient is same. So this is 15, 15, 15. So then for this one, we are expecting up to first 32. So this is time and displacement S in meter or D in meter. So we know that when t equals 0, distance is 0. So this is the starting point. And t equal 32, I need to find D. So I need to find this area. What is this area? 32 times 15. This one. So 32 times 15, that is 480 meter. So up to 480 meter, so this is 32. It has a constant velocity. It's constant line graph. When you find the gradient, what is the gradient of this one? 15 ms minus 1. When t equal 1 also 15, t equal 2 also 15, 3 also 15, 4 also 15, 5 also. Likewise, can you see that it is constant? Then I'll make it a bit smaller. 480 meter and 32 here now, because I need a space. This length we found out 12 this time. So then 32 plus 12, 44. So after 44, we need to find the distance traveled by 44. Or we can stay with the total distance. So S1 plus S2 equal 570 meter. Now I'll bring a bit closer. Then 32 by 44, 480, 570. So this is 570 meter. Now this is 44. And in this point, at this point, we know that at this point velocity is 0. When t equal 44, v is 0. V mean what? ds over dt equals 0. Gradient 0. Gradient 0 when a graph is parallel to now when you draw a maximum like this. The maximum mean what? It is parallel to the x-axis. When it is parallel to x-axis, what is the gradient? Gradient is 0. Basically at this point, so at the peak, so the gradient has to be 0. Do you think this deceleration is a uniform deceleration? So if it is uniform deceleration, the velocity is reducing constantly. Or we look at like this. Now you can see that every minute, so this velocity is deceleration reducing. Now in this curve also you can see that when velocity is reducing, what will happen to distance? Distance also getting less. So V equal S divided by T. And if T is fixed, let's say T equal every 1 minute, then V equal S. It means V proportional to S. So what I want to emphasize is you can see from the graph that the gradient is reducing and gradient become 0 here. So at 44, gradient equals 0, which is velocity equals 0. Question number 3, the velocity time graph. Actually before that, so just when you have free time, just study the displacement D and T graph. What will happen? The graph is something like this with the given T. Or what will happen? What is about the gradient? Study about the gradient. So what kind of gradient is this? What kind of gradient if the curve is like this? Just take an idea about it. So let's start number 3. This is a standard one. This is U, and this is V, and this is T, and we want you show that the V equal U plus AT. V equal U plus AT. The acceleration is the gradient of VT, velocity time graph. So acceleration, let's say A, then gradient. How do you find the gradient of this one? So this is this point 0 U, and this point is TV. Change in Y over change in X. So V minus U over T minus 0. So gradient is V minus U over T minus 0, which is A equal V minus U over T. So cross multiply AT equal V minus U. Then U bring to this side, U plus AT equal V, which is V equal U plus AT. The other one is S equal U plus V O divided by 2 times T. Area is or distance is area of V velocity time graph. Distance S equal area of trapezium. So that is half I will write AB plus H, but half A is going to be, so those are the two parallel height, U plus V, and the perpendicular height for in between parallel is T. So this is S equal U plus, I'll bring this 2 inside, so times T. Now we want to show that V square plus U square plus equal to AS. Now when you look at this two equations, which one is missing here? t. So then you have to substitute, get rid of t from here. That's all you need to do. From 1, okay, v equal u plus at, t equal v minus u over a. From 2, s equal u plus v over 2 times t mean now we can write not from 2. This is the substitute 3 into 2. So s equal u plus, then t is v minus u over 2. Sorry, t v minus u over a. This is the t. Now I will rewrite this one. U plus v, I will make v plus u. V plus u over, this is v minus u over 2a. So s equal, this is, we can write v square plus difference of 2 squares over 2a. Then cross multiply 2a is equal v square minus u square. So then u square come to this side. 2 u square plus 2a is equal v square. So v square equal u square plus 2as. Now s equal ut plus half a. We want to show that. Now which one is missing from here? You can see that u is here, t is here, a is here. The missing part is v. So what we could do, we apply this one to here instead of v and will work. So we want to vanish v to get this one. So s equal u plus v divided by t, right? From 1, s equal u plus, what is v mean? Again, u plus at over 2 times t. This is 2u plus at divided by 2 times t. S equal 2ut plus at square divided by 2 is equal to u2 t divided by 2 and at square divided by 2. 2 to 2 cancel out. S equal ut plus half at square. Next one is we need s equal vt minus half at square. Now you can see that in here u is missing, so vanish u from those two equations. From 1, u equal v minus at, and this is going to be 4. Substitute 4 to 2. So s equal u mean v minus at. This is again plus v over 2 times t. So s equal v plus v 2v times t 2vt over 2 minus at square over 2. So s equal vt minus half at square. Question number 4. Cyclist when he monitor from here, so he fart with 15 ms minus 1 constant velocity up to 15 seconds, and then is decelerate the rest. So this is the journey, and the distance is given 152 meters, and we need to find the u. So it is easy that S equal the area of trapezium, which is half a plus b times h. So these are the two parallel lines. So 100 S equal half a times this height is u. This length is 15. This length is 23, and perpendicular height is u. This is equal to 152. So 15 plus 23u mean 23, 33, 38u equal 152 times 2. So 2 to 2 will cancel out. This is 19. U equal 152. U equal 152 over 19. That is 8 ms minus 1. So this is speed is 8 ms minus 1. Question number 5. A car traveling on a straight road slow down with the constant deceleration. The car passes a road sign with velocity 40 and 24. So 40 km minus 1 and 20 km minus 1. So there are two velocities. We will need to turn into the standards. So this is going to be 100 over 9 ms minus 1, and this is 20 times 1000 divided by 3600. That is going to be 20 over 3 ms minus 1, and the traveling distance is given in between is 240. If you draw a graph, it's something like this. Let's say the sign is here. It is going to be 40, 100 over 9 ms minus 1, and up to here this is going to be 20, which is 20 over 3, and this distance is given 240. Then this is t, and we need to find the deceleration. So this is going to be u, this is v, and this is s. The equation is we can apply v square equal u square plus 2as, because we have the starting velocity, ending, and we know the distance given, and then we need the acceleration. We can take straight a equal v square minus u square divided by 2s. So this is going to be v square v minus u, v plus u over 2 times s. This is 100 minus v is 20 over 3 minus 100 over 9. This is going to be 20 over 3 plus 100 over 9 divided by 2 times s is going to be 240. So we'll get the answer as minus 0.165 to 2SF. Question number 6. A particle is moving along the x-axis with the constant deceleration 2.5. This is going with 2.5 ms2 deceleration. At t equals 0, t equals 0, p passes through velocity 20 in the direction of x increasing. At t equal 12, P is at the point A. So point A. Part A, find OA distance. Okay, so this kind of sum is, so we have two options. This A either here or sometime A is go and come up to here. Now this 2 equal 12, we don't know actually it is up to here or up to whole journey. It's not a matter we to find OA. We'll put so this is A. We have U is 20 ms minus 1. A we have 2.5 ms minus 2. T after 12. And we need S. So this is the equation. S equal ut plus half at square. Then we can find this length. U is 20 times T is given 12 plus half 2.5 negative. So this is the direction and this is a deceleration. So this is going to be negative 2.5 because of a deceleration. Minus 2.5 times 12 square. So this answer we will get 240 minus 180, that is going to be 60 meter. Now I'm not sure this 60 meter, yeah, from here to here, that's fine. And yeah, OA is 60 meter. So total distance P to A. Now I'm not sure this is this distance or this whole length. So what I'm going to do, I will consider this point. This is 0 at this point when it is turning. So U equal 20, V equal 0, A equal A equal 2.5 ms minus 1. So V equal U plus AT. So I'll just check about the T. T equal V minus U divided by A. So V is 0, U is 20 and A is minus 25. So this is going to be 8. Okay, from here to here journey 8 seconds. It means it has a this other turn as well because 12 seconds mean it is more than 8. Now we'll find the total distance from this journey. Then we can find the total travel distance for this one. U equal 20, V equal 0, A equal 2.5. So S we need to find. V square equal U square plus 2AS. So S equal V square minus U square divided by 2A. That is 0 minus 20 square divided by 2 times A is minus 2.5. So this answer is going to be 80 meter. So total distance is now 80 meter and this is 60 and this is 20. Then the travel distance is 80 plus 20. Hence the travel distance is 80 plus 20 is 100 meters. Question number 7. A ball is thrown vertically down on top of a tower. With the speed of 6 ms. Ball strike the ground with the 25. So it will hit with 25 ms minus 1. Find the time t. journey time. So we will take this direction is positive. So then v equal 25 ms minus 1, u equals 6 ms minus 1. A is 9 to this direction, 9.8 ms minus 2. We need t, so v equal u plus at. T equal v minus u divided by a. V is 25 and this is 6 divided by a is 9.8. This is going to be 1.9 to 2 significance figure. 1.9 second. Question number 8. A child drops a ball from the top of a cliff which is 82 meters. So the cliff is 82 meters and child drop a ball with the initially at rest. So this is 0 ms minus 1. The u is 0 ms minus 1. S is given 82 meter. So we'll take this side is positive. A equal 9.8 ms minus 2. Question number 1. The time taken to reach the sea. So let's say t. S equal ut plus half at square. So S equal u is 0 times t plus half 9.8. So this is the direction and t square 12 square. T is the thing we need to know, and S is given, that is 82 meter. So t square equal 82 times 2 divided by 9.8. So approximately t equals square root 82 times 2, 9.8, that is 4.12 to 2 SF. The part B, we need to find the speed v. So we'll put v equal to as. So v square equals 0 square plus 2 times 9.8 times 82 meter. So v equal, this is going to be 102. So v equal square root 1 2. So this is going to be 42 to SF. Part C. State your physical factor which has been ignored in making your calculation. Mainly the air resistance. Air resistance is disregarded. Question number 9. This is a particle movement. The distance traveled is 451 meters, and we need to find u. That's the question. So we know that the area is the distance. Area of the graph is the distance equal 451 meters. So we'll find the area. So then only one unknown we have. Then we can solve the equation. So area is S1 plus S2 plus S3. So S1 is half a times this height perpendicular 8 times Okay, we'll take any perpendicular. So this is 2u. So 2u, this is going to be 4u. Sorry, this is going to be 8u. And S2 is, this distance is 12 and this height is 2u. So 2u times 12, that is 24u. And S3 is a trapezium, that is half a u plus 2u. So those are the two parallel and perpendicular distances. 26 minus 6, that is going to be 6. It means this is going to be 3u times 3, that is 9u. So then S1 plus S2 plus S3 equal 8u plus 24u plus 9u equal 451. So this is going to be 24, 9u, 8u, 41u is 451. So u equal 451 divided by 41, that is 11. Part 2. The part B, the distance moved by the particle with speed less than u. So this is the speed. So speed less than u, particle travel up to here. It means this is the triangle we need. We know by symmetricity this is going to be 4. So then this area of this one, let's say S4. So S4 is half a times 4 times u, which is half times 4 times u value we know 11. So 2 times 11, that is 22 meter. Question number 10. A train traveling with a constant acceleration in a straight track at t equals 0. The train passes through point C O, traveling with t equals 0. Point O, traveling with 8 ms minus 1. And then t equal 12. Point passes P with 24 ms minus 1, and then t equal 20, this is point Q. So the speed of the train at Q. So we'll consider this journey first. And OP journey. U equal 18 ms minus 1. V equal 24 ms minus 1. Time taken is 12. And we can find acceleration, because to find to PQ distance speed, V equal U plus AT, but we don't know A. So now we can find A from here. So V equal U plus AT. So V is 24, U is 18, T equal 12. So this is going to be 6 over 12, that is half a ms minus 2. Now consider PQ journey. For that, then U equal 24 ms minus 1, we need and t is 8, 20 minus 12, and we can work out now. V equal u plus at. So u equal 24 plus a is half a times t is 8, that is going to be 28 ms minus 1. So part B is the distance to P to Q. So we can apply S equal, we have few options. S equal U plus V divided by 2 times D. S equal ut plus half at square, or V square equal U square plus 2as. But when I look at these, all contradicts, so I like to stay with this one. S equal U is 24 plus 28 divided by 2 times t is 8. So this answer is 280 meters.